Assalamualaikum, my name is Aman Aris Akmal, number matric CE200145, and for this video I'm going to show you how to insert materials and also condition towards this geometry that we have created. So for the people who is curious about the geometry and how I created it, please watch my previous video. So now let's look at our table at material. I'll show you the material. So the part is rotor, stator, armature coil. The part needed is steel 3 to 5. And the question is rotation, nodal force. So this is the table. So let's start for it. Okay, first to start, we need to new study on TD model. Right click, new study, and transient analysis. So we start from there, and now we can look at our materials, which is at the toolbox. At the toolbox area in the right, we'll find our materials. So first off is we start off with the stator, and it uses 35H210. Oh, sorry, 35. So another material. Here it is, and we just drag it to the stator, and then we click OK. And now we can see right here. Oh, sorry. Stator is right here. Okay. Okay, the stator and the rotor uses the same material, so it's the same. So for the armature coil, now we need to drag conductor. So we need to put in conductor copper. So we put in copper right here. Click OK. Copper right here. Click OK. Copper right here. Click OK. Copper right. So all four parts of it has copper right now. So copper. All four of them has copper. So we're now done with the stator, rotor, and also armature coil. Now the left is the permanent magnet. So in the toolbox we need to put in JMAG 35 AH permanent magnet. So from the table we should use the irreversible one. So we just drag in right here, and we need to choose the radial pattern for the circle directions, which is this, and the pole is 2. And then we click OK. Same as the left one, we just drag it, change the radial pattern, which circular direction, and change the pole to 2, and click OK. So now we should also look at the direction itself of the we just put. So because you can see the direction is going towards the right, but the left one, and that is correct. So we need to check the right one. Also it's going to the right. So this is correct. So now by now we have already inserted every material into the design. So now we can create the circuit. So to do that, we need to right click and add circuit. So this is a simple task. We just use 2 coils and 1 ground, which is right here. Now we just connect the connection, and we need to set the rotation. First we need to put 10 for coil 1, coil 2 at 10 as well. So yeah, that's the requirement. So we can just close the tab right here because it's already done. And on the circle section on the left, you can see the added coil 1 and 2 is already here. So the circuit is already done. So now for the conditions, we can see it right here below the material toolbox. We can click okay. Now we're going to start with the rotor, which we need rotation. And so the motion folder, we have rotation. You just drag it to the rotor, which is right here. Rotor, and RPM is 1200. And we should include the permanent magnets because it move alongside with the rotor. So we click OK. And then the nodal files, we need to add nodal files for the rotor and the permanent magnet. So we are going to use the torque as mentioned as the same one. Okay. Now we click OK. We did click OK. Everything's done. The conditions is good. So now we're going to use the FEM coil. So for the FEM coil, we just drag it. Okay, and we set it. For the top one, we need to use it downwards, and we click OK. And then down, and here we need to downward. Click OK. I think we need to link the coils. For that too, we need to add coil 2 and link it to here and upward. Okay, this is correct. Link to coil 1 and this is correct. Click enter, and for the enter to 4 need to add coil 2 and this is also already correct. So we click enter. So for now we have 3 and 4 coil, and this is correct. As you can see, every part has its condition and part already. This is the condition and this is the material. So now we can we are finished with I think we are finished with the linking and materials condition. So now we can run it. So but before that we should check on the properties of the graph, which is number of step. We are required to put 37 time step. Time step we should use 0.05, and also the conversion where we put the division. The division. Oh, we need to change the regular intervals. Yep, like this. End time 0.05. The division is 36. The conversion is stack length uses 25 mm. So yeah, this is all correct. We click OK. Now we set the mesh. So we right click, we add size control. We hit properties first, and we need to use slide mesh. So this is important for us to get no errors. So we click OK, and then we hit mesh again. We go to add size control part. So we need to choose every part. So it's 0 already, so change it to 7, and we click OK. Now we can try to run the design. Okay, we can wait for the design to run, and let's see, there were no errors. So okay, that is good for us. We have no errors and the design is correct. So now we can check the results by going to the graph, right click, and we can check the graph. Here's the torque value, the table, and we can check the Lorentz force. It's the absolute force table, and we can check the coil flux. And this is the coil flux for turn rotation, as we said before. This is the value which is the peak is the same, but in negative and positive it's just a rotation of going up and down. So if you want to change the FM, we need to change it by the rotation of the coil, which is the circuit, by edit circuit. So this is with, as we edited, this is 10 coils. as well. So first we need to stop it. Stop the circuit. Can't stop it now. How do we stop it? Steady. Restart. Cancel. Edit circuit. We cannot edit the circuit as the circuit is running. So yeah, that is all from this part of the design for 2D transition, and I will continue on with the 3D.